being the... Okay, so here we go. So yesterday we worked on implicit differentiation, and I swear if they had like rotten fruit or rocks or something, they would have, you know, I would not have survived the day. They were not very happy with me.
It wasn't as bad as today. Evan had his tantrum.
So, right, which we,
I was like, so
you were voted off the island early on. All right, so yesterday we found the first derivative using implicit differentiation. Today we're going to find the second derivative, okay? So in order to find the second derivative, we have to find the first one first. So if I start...
Find the third one?
No, that's only two things there, okay? And that is in your book also, Miss I need glasses.
I don't need glasses. Well, where's the one with y to the end?
Yeah, I thought it was y to the end.
Okay. All right, Evan, you ready?
yeah.
Okay, all right, so first derivative, what's the derivative of x to the fourth?
Wait, hold on, I have to write it.
Wait, what page is this on? I like it.
Oh my goodness. Okay, all right, so the derivative of x to the fourth is 4x cubed. Everybody in here can get that. Okay, then what we picked up on yesterday, so Christian, this is a little bit for you because you were taking that quiz, is to take the derivative of y to the fourth. We're using the chain rule, right? So the 4 goes in front, 4y cubed, but then we have to also take the derivative of this function here, and the derivative of y is the derivative of y prime. Okay, equals the derivative of 16, which is 0. Okay, no soccer in here. Okay.
You only do the chain rule.
I do the chain rule on the first one too.
But it's just one.
So yeah, so if I take the derivative of x by the chain rule, x to the fourth, it's 4x to the third times the derivative of x, but the derivative of x is 1. Okay, so we don't need to write that. Okay, Gabby? Okay, all right, so now that we have that figured out, what do we have to do next?
Derivative again.
No, not yet. What do we have to do
Oh,
first?
solve for y prime.
Right, we have to solve it for y prime, okay?
Oh, because then
Yeah, it's going to be, I mean, you could maybe go through and do the chain rule and the product rule and all that kind of stuff, but it's going to be messy. Yeah, so it would be easier to solve, yeah, right. Okay, yeah, it's messy enough as it is here. Okay, so I'm going to subtract 4x cubed from both sides. So 4y cubed times y prime equals negative 4x cubed, right? Okay, good, that's a good start. And then divide both sides by 4y cubed. And so you find the first derivative is going to be negative x cubed over y cubed, right?
because the 4
Because the 4 is canceled.
That's what I was excited.
Because you knew to cancel the 4.
Yeah.
Top students, right? Excited that the 4 is canceled.
Now,
Okay, hold on. Now we're going to let Trish finish writing it down.
so we have to do the quotient.
Hold on, slow down.
We have to use the quotient rule.
Hold on. Yes, we will.
Okay.
Okay, you got it? All right. So now to find the second derivative, we actually have two options. We can do the quotient rule the way it's written, or we can do the product rule if we rewrite it with the negative exponent.
All about that product.
You like the product rule better? Okay. Taylor, do you remember the last time you made us do it your way?
Yeah, but
When Mr. Pugh was in here?
What way did you do it?
Okay, definitely the product rule. Quotient rule is a mess, okay? All right, so we'll rewrite it like that. Okay, now we are going to use the product rule to take the second derivative. Okay, so the second derivative is the first function. Right, so negative.
You're waiting for us to say.
I'm waiting for you to say it's the first function times the derivative of the second function. What's the derivative of the second one?
Negative 3y and negative 4 times y prime.
Awesome.
Hold on. Wait.
Okay, so that is the first function times the derivative of the second. And go out, I'm going to try and make the little things like slanted so they don't look like to the first one. Okay.
So the y
Plus,
prime-
just trust me, I will never
Oh,
write
wait,
to
so
the
you
first
have to
one.
have the y prime in there.
Yeah,
Because that
anytime
comes-
you're taking the derivative of y, you need to have the y prime in it.
Why would there be y down there?
Okay, all right, plus So that was 1d2 plus 2d1, right? So the second one is y to the negative third times the derivative of the first one, because this was our first function and this is our second one. So the derivative of the first function is 3x squared. Okay? Oh, sorry, didn't see that negative. Okay?
I can change our whole answer.
Okay, now, here's why this is fun, is because we're not done, okay? And I heard Gabby and Connor sort of having the side conversation about we've got the second derivative and the answer is in terms of the first derivative, but we don't like that, okay?
So do you just plug in the?
Right, so we know what the first derivative is, and so we're going to plug that into here.
Then we're done.
That just
Then we're done. We don't have
Okay,
to stop.
we're gonna simplify. You're dropping this class tomorrow?
Yes.
There's
Fail.
probably time.
Yeah, you'll take it after. Yes. I can deal with it if I don't have to go through this part.
Okay, so I'm gonna rewrite this. Instead of having the y prime in there, I'm gonna write what we figured out y prime equals. So that is negative x to the third, y to the negative third, plus, still have y to the negative third times negative 3x squared. Okay? So that's not bad, right? That's terrible.
I'm not simplifying though.
Oh, yeah. Okay, so if we simplify this, we've got a negative, a negative, and a negative, so that makes a negative. Then I want my numbers in front, so that's going to be 3. X to the third times x to the third is x to the 6th. Okay, and then y to the negative fourth times y to the negative third is y to the negative 7th. Okay, plus I have a positive times a negative here, which will give me a negative, and then 3x squared y to the negative third. Okay, that's so much prettier though than the first one. That is our final. Oh, you want to factor out an 3x squared? Can I factor out a negative 3x squared? Okay. So that'll give me, what did you say, Connor? Okay, let's practice that because that's going to be something that you're going to have to work with later. So you said factor out. Now this is important because we're going to later have to do some algebra with this solution. So we're going to need to be able to factor it. Okay, so if I factor out a negative 3x squared, let me ask you this simple algebra question. Why did you choose to factor out an x squared and not an x to the 6th?
Because you can't take.
Because this is smaller than that, right? Okay, so if I'm going to factor out the y's, what power of y should I factor out? Yeah, I'm going to factor out a y to the negative 7th. Because even though your brain tells you that the 7 is bigger than the 3 since they're negative, it's the opposite. Okay? So that leaves me with x to the 4th. I factor out a negative, so it's going to be plus, right?
Yeah.
What would I have to multiply y to the negative 7th by to get y to the negative 3rd? Y to the 4th, right? Because when you're multiplying, you add the exponents.
Oh,
Okay.
that's nicer.
And it's way nicer because, wait, Connor sees it. Yeah, Leanne sees it. What? What does x to the 4th plus y to the 4th equal? 16 from the original problem statement. So since we ended up with x to the 4th plus y to the 4th, I can replace that with 16 and get the nicest answer of all. Negative, we almost didn't do that. Negative 48 x squared y to the negative 7th. Okay? Which is, even Taylor will agree, not Pula, she's so
pretty
cool
nice.
with this.
That's
Way nicer than this right here.
I would never be
Okay,
able to get that.
so, second derivative, same as the first derivative. You just take your answer and take the derivative of that, and then you need to substitute back in, and then all kinds of fun magic can happen from there when you simplify. Okay? What's that?
Is this?
Oh, okay, great question. So Mary says, what does this answer represent? Right? Okay, right. This would be, remember that we're talking about derivatives as functions now, right? So when we found this first derivative, even though this is an implicitly defined equation, we could come up with a graph for this.
It's an imaginary graph.
It would be a real graph. No, it would be a real graph. I mean, we could make an XY table and plot those points and come up with a smooth curve. Maybe we could take this and solve it for Y or something. There is a way that we can graph this. It would not be a function. Okay? It would fail the vertical line test. It would wrap around over itself, but it would be a graph. Okay? So the second derivative of that is the derivative of the first one. So it would be the slopes of the tangent lines of this graph. Okay? Now, as it turns out, later in this class, in the next chapter, I think, the graph of the second derivative does tell us things about the original graph. Okay? Remember we talked about the first derivative. What's true when the first derivative equals 0? What's true about the original graph? The slope of the graph is 0, so let me, so if I have a graph that looks like this, okay, where is the derivative of that graph equal to 0?
At the minimum and maximum.
Right, good, at the maximums and the minimums right there, okay? So the first derivative, when that equals 0, that tells us something about the original graph. That tells us where the maximums and minimums of that original graph occurred. We also talked about when we made graphs of the derivative by hand, what is true about the slope of the tangent line between this maximum and minimum. It's negative, so where the derivative is negative, what's true about the original graph? It's decreasing, so we talked about that too. And then where the graph is, where the derivative is positive, the original graph is increasing, okay? It turns out, like I said, there is some information that we can find about this graph from the second derivative also, okay? But we're not quite ready to get there yet, okay? So just, you don't think you're ready when, we'll be ready when we actually do that?
No, I said I don't even think we're ready to get where we are.
Oh, okay, but we got there anyway, all right? Okay. So,